Hello everyone and welcome back to the channel. This is CCNA Day 19. I'm going to speak about wildcard masks. So you think, why did I not continue with dynamic routing? The most important part of dynamic routing is understanding the configuration. A part of the configuration is preferring some of the interfaces on the router for creating an adjacency with the other interfaces on the other routers, which means that I need to be selective about which one of the interfaces are going to create an adjacency. In that case, wildcard mask is one of the parts that you need for the configuration. This is not just that. Wildcard masks are used on access control list, which is a very, very essential part of this. When you do this, if you do not understand wildcard mask, you cannot really configure any access control list. So let's just go for wildcard mask. What is it and how we are going to use them, how to calculate the correct mask, and finally, how we can have them in an access control list and open shortest path first protocol in CCNA exam. Okay, so the first thing that we need to know is wildcard mask is inverse of subnet mask. So you already know what subnet mask is, right? So if I want to specify a specific IP address, so say that I have a network in here, and inside this network I have a specific VLAN, and for this VLAN I assign a subnet. So the subnet could be something like 192.168 and then 10/24. So this is /24 in the end is a subnet mask. If I want to convert it into 32-bit subnet mask format, that's going to translate to 255, 255, 255, 0. This 0 in the end means that this part is up to you. You can change it as you wish. This 255s means that this part cannot be changed. Everything that is in here is going to be exactly the same as what we have. So if I want to put it in here, so 192, 168, 10, and at the bottom of that I write 255, 255, 255, and 0. This means that this part cannot change, this part cannot change, and this part cannot change. But this part can change. You can go from something like 0 up to 255, which is the range of the possible values for this specific object, right? How can I tell this part cannot change? I'm just going to make it a little bit more precise and more explained. So 255 is something like 111111111, right? So that's 8 bits. All of these bits are 1. When I have subnet mask, every one that you see in here says that whatever value is for the IP address, it cannot change in here. So 192, whatever the conversion to bit value is, it cannot really change it. So the bit value for 192, if I remember correctly, is going to be something like 11000000, right? So that's 192. So what does it mean? This means that whatever the value up there is cannot change. So one says this one cannot change, one says this one cannot change, this one says that this 0 cannot change, and so on and so forth. So at the end, 192 cannot really change for the result, which means that this part of the address is fixed. This part of the address, of course, is going to be fixed, and this part of the address is fixed. But what about the last one? We have something like, in the end, some zeros for the last octet, which is going to be 000000000, which means that whatever the value is up there can change. So we can have 1 here or 0, doesn't matter. We can have 1 here or 0. Whatever that is up there can change. So that is subnet mask. Now let's convert this to wildcard mask. So every one here in the subnet mask can change into can change into 0. And every 0 can change into 1. Now 0 means cannot change anything about the address. 1 means yes, you can change it. Or 0 means must match. 1 means ignore whatever is there. That's okay, I don't care. Must match means no, I can't. It should not be changing. Okay, so this is the basics of wildcard mask. And I'm just going to give you another example of that which I have not put in the slides. Something that is used for wildcard mask is you can use this in a mathematical way to select a range. That is very much used for access controllers and also interface selectors. So let me just give you an example. If I say 192, 168, 10, and like I said, wildcard mask is exactly the opposite of subnet mask. So every 255 is going to change into, let's say, 0. So another 255 is going to change into 0. Another one is going to change into 0. And finally, what we have is 255. So that is the opposite of that. So what can I do? This tells me that any address starting with this plus this is going to be accepted. So the starting address is going to be this one, and the final address is going to be this. 192 plus 0 is going to be 192. 168 plus 0 is going to give me a 168. 1 plus 0 is going to give me a 1. And finally, 0 plus 255 is going to give me 255, which means that the beginning address is going to be 192.168.10, and the last address is going to be 192.168.1.255. So that's the range of IP addresses that fall into this specific range. And how did I tell that? Just added this wildcard mask to the IP address that is the beginning of the range. So that is an interesting calculation. Very easy to understand and very easy to follow. So let's go for the next slide. So we have subnet masks. Like I said, subnet mask is going to give you a strict matching. I just gave you what subnet mask is. So in here, let's say, for example, I have 255, 255, 2550. Or I can, this means that this is going to be 24 bits, right? So every octet is 8 bits. So we have 3 of the octets completely 1. So this means that 3 of the octets are going to translate into 255, which is the decimal value for all ones in that octet. What if I add more ones? Then let's say, for example, here up to 192, I have something like 24 up to here, and then I have another 2 here, which means that 6 bits are zeroed and 2 bits of the last octet are ones, but these are contiguous, right? So why a subnet mask is contiguous. So this means that if I want to translate this into binary, that's going to give me 1111111, 11111111, 11111111, and finally I have 11000000, right? You can see that all the ones follow each other, right? So subnet mask, like I said, is strict in following the ones. So this means that all the values over this ones are going to be strictly the exact value that they are, but anything over these zeros, they can change. They can be 0 or 1. I don't really care. What about 248? That's going to be something like, I guess 3 bits, right? Something like that. 3 bits are going to be 0. The rest of the bits are going to be all 1s. But the thing is, when you go for wildcard mask, I don't really have to I have zeros in here. Zeros do not have to be contiguous. So this can be, for example, 0, the first octet, the second octet could be whatever value, the third octet could be whatever value, the fourth octet could be whatever value. Here we have some examples of contiguous zeros, but they don't have to be contiguous. They don't have to be all zeros and then all ones. So wildcard masks are very flexible. So we say this is flexible matching. Okay, let's go for some simple formula. How can you understand how to configure wildcard mask, how to calculate wildcard mask? So whatever the subnet mask is, you can just subtract it from 255. So say, for example, this is 255, 255, 2550. You can subtract it from 255, 255, 255, 255, and the result is going to be this. So 255 from 255, that's going to give me a 0. Another 255 subtracted from 255 is going to give me 0. The last one is going to be 255 because I am subtracting 0 from 255. So you can see that by subtracting the subnet mask from all 255s, you're going to receive a wildcard mask, which is very easy. Same thing is going to be in here. So you can see that the wildcard mask is going to convert into 63, right? From 255, I just subtracted 192, and that's the result. 63. Now, when I go with access list, like I said, I select a beginning and the end of the address, and I'm going to receive a range. Based on that, I can just configure the wildcard mask. So if I have 10, 1, 1, 50, I can just add this to here. 0, 0, 0, 0. So 10, 1, 1, 50 is going to be the beginning address, and 10, 1, 1, 50 is going to be the end address. So this means that there's only one address which is going to match. So 0000 means that exact match that we have in here. Like I said, you can just add the value to the beginning address, and you're going to receive the ending address. And when you see the ending address is exactly the same as the beginning address, this means that only one address is going to be permitted with this. So matching a subnet, of course, is going to be possible with wildcard mask, and also ranges. I showed you how we can do that, and based on this, you can understand what is the beginning and what is the ending address. A wildcard mask are using OSPF in EIGRP, and that's going to select some range of interfaces that are going to fall into OSPF process. And based on this, you can tell, for example, any interface that I have that start with 1010, and why should I say start with 1010? Because the first two octets are 0, right? Any interface that have an IP address of 1010 whatever, is going to fall into area 0 for OSPF. And this is going to give me a range of stuff in here. And some interesting things that we can do with wildcard mask. You see this value, 0001 as a wildcard mask. We can use them to select odd numbers and even numbers when we select IP addresses. This one could be, of course, in any of the octets, but in this case, I just selected this as the last octet, right? So it gives me this value, 192.168.10/24, and they tell me that this should be applied to here, and only the values could be selected that we have the binary value of this in the end as the wildcard mask. Let me just convert this to binary. That's going to be easier. The last octet in binary is going to be 0, 0. Let me just write it again. 000000001, which means that this can play. This can change. This means that this can be 0 or 1. But I'm just matching exactly. When I match exactly, this means that only the values in the end with non-changing, something that is something like 0, as they tell me, I'm just going to use. So if I just convert this into binary, that's going to give me 0, 0, 0, 0, 0, 0, 0, 0. So this one and this one. This one, these two are important. This means that I just care about this last one. I don't really care about these. So in this case, when I am matching this, these two are going to be not important. But let me just see what is going to give me. This means that the last bit should be 0, right? When I have the last bit 0, it's going to give me even numbers. So this is going to be 192, 168, 1, 0, and 2, and 4, and 6, and so on and so forth, because the last bit for them is going to be 0. And if I give them 192, 168, 1, 1, let's say /24, this is going to be applied, and because this one has the last bit as 1, everything that has the last bit as 1 is going to be selected. So that's going to give me 192, 168, 1, 1, and 3, and 5, and 7, and so on and so forth. So that is how you just select odd values or even values when you want to match exact IPs. Okay, so we're almost done. I gave you how you should calculate different, wildcard masks. That's very easy, right? Subnet mask subtract from 255. That's done. That's going to give you the wildcard mask. And I gave you an example of your access list. So in this case, for example, if I want to say any address that falls into 172.16.4.0 up to 172.16.7.255, this is going to give me this wildcard mask, as you can see in here. And because I told you how to calculate this is going to be an example for you just to do it yourself. Some tips. If you say wildcard mask of 0000, like I said, when you add it to a range, that's going to give you only one address, which means a single host. This is going to give you a /24. So wildcard mask is the exact opposite of subnet mask when you do the configuration. Okay, in this video, we had very interesting things about wildcard mask, and that is important to understand. Later videos, we're going to continue with dynamic routing, and you can see that this wildcard mask has to be, spoken about so that you would be comfortable with the rest of the videos. So thank you for watching. Like always, I ask you to like and subscribe to the channel, share these videos with your friends, and also hit that bell button so that you're going to be notified. So see you in later videos.